All right, here's example 3.10, the last one from this section of pre-calculus OpenStax. We're asked to evaluate I to the 35th power. We're simplifying powers of I. And before I do that, I want to figure out what is -1 to, I don't know, maybe the 7th power. And you're like, -1 to the 7th power, that's easy, it's -1. I just know that. Well, how do you know that? Well, I don't know. I guess if I really had to explain it to somebody, I'd say it's because if I multiply -1 times itself 7 times, I already wish I had chosen a smaller exponent. Is that 7? 1, 2, 3, 4, 5, 6, 7. If I multiply these all together, I get -1. How do you know? Well, because any pair of them, -1 times -1 is +1. So I can multiply these two together and get +1. I can multiply these two together and get +1. I can multiply these together and get +1. But then I have this negative sitting around here. So 1 times 1 times 1, I don't worry about any of that. But this negative makes the whole thing negative. That's true. But you probably don't go through that analysis when you're doing the problem. You probably just recognize that a negative number raised up to an odd power is always going to be negative. And a negative number raised up to an even power through a similar argument is always going to be positive. Well, it turns out you can do something very similar with powers of I, except that it matters, it's not just whether the exponent is even or odd. Really what ends up mattering is what is the remainder upon division by 4. So let me try to talk through why that works out. If you have I, well, okay, how about this? I know that I squared, I know that I equals I. And like, whoa, that's a weird thing to write. It'll make more sense in just a minute. Because I squared, I know by definition is -1. And using these two facts above it, I can figure out that I cubed, well, I cubed would be I squared times I. And I squared times I is I times -1. In other words, this must be the negative of I, which is kind of interesting already. And I to the 4th power, well, you can either think about that as I cubed times I, or you think about it as I squared times I squared. So I like to think about it as I squared times I squared. I to the 4th is I squared times I squared, which is -1 times -1, which is +1. And the fact that I to the 4th is +1 will be really useful, because that'll also tell you that I to the 8th power is +1, and I to the 12th power is +1. Because of the same argument, imagine if you were writing out I to the 8th power. You could write out I times I times I times I times I, blah, 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 at all of these, but you wouldn't need to write them all out, because you could really be like, that's just 2 groups of 4. Right? This is I to the 4th times I to the 4th. And I know I to the 4th is equal to 1, so this is just 1 times 1. A similar argument to what we made over here would tell you that I to the 8th is equal to 1. And similarly, I to the 12th is equal to 1, and I to the 16th. In fact, any multiple of 4 as my exponent is going to leave me with just 1. So when I'm given a problem like I to the 35th power, what I like to do is think about how many groups of 4 can I make. Well, unfortunately, 4 doesn't go evenly into 35, but 4 does go into 32. Right? 8 times 4 is 32. So I could think about this as 8 groups of 4 with 3 i's left over. And the reason it helps to think about it like this is I to the 32nd power, just like I to the 12th power, I to the 8th power, I to the 4th power, etc., is just equal to 1. And as I wrote up here, I to the 3rd power is equal to the negative of I. And when I multiply 1 times anything, doesn't change the value of that anything. What I get for my final answer is just negative I. When you're doing these problems, all you got to do is look at the exponent and figure out what is its remainder upon division by 4. When I divide 35, when I do 4 divided by 35, maybe you throw an 8 up here and you say 8 times 4 is 32, and then you subtract, and 5 minus 2 is 3. And then you're like, no, I can go further. I can put a decimal here and a 0 and figure, yeah, I don't need, we're going back to like elementary school long division, when you didn't get decimal answers, when you stopped here and you said it's 8 with the remainder of 3. All you care about is the remainder of 3, because what this is saying is that 35 is comprised of 8 groups of 4 with 3 left over. And each of those groups of 4 is just equal to 1. So I don't even have to concern myself with it, just like each of these groups of 2 is just equal to 1. So I don't even have to concern myself with it. All I have to worry about up here is what is the remainder upon division by 2. If I take 7 and divide it by 2, I got a remainder of 1. 2 divided by 7. 3, 6, 1. I get 3 with the remainder of 1. What that's telling me is negative 1 to the 7th power I can think of as 3 groups of 2. Here's one of the groups, here's another group, here's another group. And each of those are just equal to 1. And then I have this one negative 1 left over. I know you don't think about it that way, but if you can think about it that way, it makes this make a lot more sense. It's just now that I don't need 2 in my group to make a positive 1. I need 4 in my group to make a positive 1. So instead of dividing by 2, I divide by 4. I divide by 4, I get a remainder of 3. What that means is that 32 of this 35 are just a whole bunch of 1s I don't have to worry about. 8 1s being multiplied together. But I still have this I cubed here, and I have to figure out what I cubed is equal to. And I cubed is equal to negative I. And that's because, if you need me to justify that, I know I already talked through it a little bit. I cubed is the same as I squared times I. And I know that I squared is negative 1. So it's negative 1 times I, aka negative I. So I get 1 times negative I, I get negative I. This is my final answer. I probably should have ended this video a long time ago.